that I
Right.
lost. Yeah. And not
Jeez.
terrific at backing up because I haven't lost a hard drive in 25 years.
Mhm. That
And
is
I
weird.
didn't think you
Yeah.
lost them anymore. I mean, I've always believed that, boy, they built them so good that they don't ever crash.
Oh, exactly. Yeah, that's what you think.
This hard drive I had for about 7 years,
Uh-huh.
and it was just completely unreadable. The guy could not recover any data on it at all.
Really?
Yeah. So
Wow.
I know.
Why is that? Did it just fry or?
He gave me some conspiracy theory that, I don't know. I think the guy was a little nuts. So I'm inclined not to believe him. But
Right.
they intentionally build them now so that they give out in about 4 years.
I hate when they do that.
I don't believe that. Nah.
That's just crap. No, I don't
Well,
believe
it's a free market system. The person that builds the best hard drive is the one that wins.
it. Right.
Not the person that builds the hard drive that gives out every 4 years so they can replace them. They don't
Yeah,
they
exactly.
don't get the market. No, I mean, it doesn't take long for the consumer to figure out who's building
Mhm.
good hard drives and who isn't. So
Right.
I don't buy his explanation at all.
Yeah, I don't think I believe that.
Yeah. We better get
Yeah.
going because I do have an 8:30 tonight.
Okay. Definitely.
So let's start with 5.
Okay.
Put this in, hold on, I'm going to have to unplug this and plug it back in.
No worries.
Yeah, that didn't take long. Huh.
Mhm.
Wish all my problems were that easy.
No kidding.
Huh.
No, it's like I've been extremely nervous. So we find out what team we made tonight for Chatfield.
Uh-huh.
But yeah, we already found out my summer team. I made varsity for that,
Oh, good.
and then yeah, so I'm hoping to make either JV or varsity for the spring. So that'd be cool.
Cool. Cool.
But yeah, oh man, nerves get to me like
I'll
every
bet.
year.
I'll bet. Oh, yeah. Performance anxiety is
Oh
terrible.
man,
I've faced that
yeah,
a lot in my life.
oh yeah,
I figured it took about 10 years off my life. So
really,
we'll find out.
yes,
But no, I've done nothing but compete my whole life. So I'm always,
oh
except
yeah,
now. That's the one thing I love about tutoring math is there's no competing. Although you do have to
exactly,
know the math. If I go into
exactly,
a new student and I don't know the math, guess what? I do not get a follow-up appointment
right,
ever.
right. Oh
So
man, yeah.
what's the log equal to here?
So wouldn't it be log base of 2?
No, remember the thing you should always remember.
Uh-huh.
Logarithms are exponents.
Okay.
That's what they are. So the
Uh-huh.
log is equal to what?
So log is equal to 2.
Right. Now
Okay.
let's figure out where the 5 and the 25 goes. Where's the 5?
Okay.
That's the base.
Okay. So it'd be log base 2
Well,
of,
already put
or
the
no?
2 somewhere. So
So
we
log
got to
base,
distribute the 5 and the 25. Got to go somewhere.
okay.
So
Um,
log base 5.
uh-huh,
That's where
is
the
equal.
base always goes. And the base is always the number under the exponent.
Okay. So it'd be
25,
log
there's
base,
only one other place to put it as the
yep.
argument.
So would it be, okay, cool.
Okay. Now,
Cool.
if we want to take this and put it back into exponential, use that little ditty that I taught you. The number
Yeah.
on the far left
Uh-huh.
raised to the power of the number on the far right
Okay.
equals the number in the middle. So
Cool.
5 raised to the 2 power equals 25.
Cool.
You
Okay.
absolutely have to be able to go back and forth between these two formats.
Okay.
Okay? If you
Yeah.
can't, you're missing the next 13 problems,
Mm-hmm.
at least.
Yeah, definitely.
So a huge skill here. Okay?
Yeah, for sure.
Now
Okay.
write this exponentially.
Okay. So now it would be log base 3 of 14 is equal to x.
You got it.
Cool.
Now write this exponentially.
So write in
Excuse me.
exponential form, yeah.
Yeah, this one we're going the other way. This one they've given it to us in logs. Now let's go the other way. Let's put it, write it in exponential format.
So it'd be 3 squared is equal to 9.
Uh-huh.
Cool. And then this one would be x to the...
Start with the number on the far left. What is that?
Yeah, so it'd be...
B. Here, let me blow it up a little bit.
Mm-hmm. So it'd be b to the y is equal to x?
Yep. That's all you have to remember is the number on the far left raised to the power on the far right equals the number in the middle.
Cool. Okay.
Number 9, evaluate.
Yeah.
Well, I've got the log, and it doesn't tell me a base, so what does that tell me it is?
10.
Okay. How do we evaluate this?
Kind of confused what he means by evaluate.
Well, this equals some number.
Yeah.
Okay, so let's add the variable. This is where I taught you to add the variable.
Right. Okay.
Now put it in exponential format. That's the way you solve them. By adding the variable.
Okay.
Now put it in exponential format. I'll add a little 10 there just to make it clearer. So what can you say?
So would it be 10 to the x is equal to 1/10?
Yep. Now, well, now you still have to figure out what x is. What's x? If 10 to the x equals 1/10, what does x have to be?
-1.
You got it.
Cool.
All there is to these problems is, okay, now let's evaluate natural log of e. What's the first thing I should do?
So it said equal to x.
Good. Now what's the next thing I'm going to do?
So now we would do...
always you got to go to the other format.
Right.
In other words, if it's in log format, you got to put it in exponential. If it's in exponential format, you got to put it in logs.
Okay.
So put this in exponential format. What's the base on natural log?
So the base of natural log, here, hold on. Let's see. Okay, so it would be, so natural log, like that, e?
Base e.
Yeah.
In other words, natural log of z equals the log base e of z. That is natural log.
Okay.
Always remember that because natural log's a biggie.
How did you get z?
I just made it up. I'm just trying to tell you what the base of natural log is. In other words, that's the same as that.
Okay.
Now put it in exponential format.
So exponential form now would be... Okay, sorry. I'm like, that's where my brain just went blank. So it'd be e to the x is equal to e.
Yeah, be careful. It's always the number on the far left raised to the power on the far right equals the number in the middle. Okay. Now what's x got to be?
And now x has to be 2.17.
No, that's the value of e. Forget the value of...
that's... So would x just be 1? X would just be 1, right?
Exactly.
Yeah, okay.
Now we got log base 4 of 64. Are we going to do this one?
Yeah.
How are we going to do this one?
So we would do z equal to x. Okay. And then it'd be 40 to the x is equal to 64.
Okay.
And then x is equal to 3.
Huh?
Cool.
Once you learn the method and the pattern, it's all actually become extremely easy.
Mm-hmm. For sure.
First step?
So say equal to x.
Second step?
So it'd be 6 to the x is equal to 20.
Ah. Let me look at what the instructions are here. A value.
Okay.
Well,
Yeah.
we don't have any way of knowing what x is because it's not an integer. I know that 6 to the 1 power is 6, and I know that 6 squared is 36. So x is between 1 and 2.
Yeah.
But what it is, I have no idea what it is. So let's go back and start again on this. I didn't realize they were going to give you problems that required a calculator.
Mm-hmm.
Well, do you have your calculator with you?
I don't. I can go grab that real fast.
Grab it real quick.
Okay. I will be right back. Dad, Johnny Cole on stay logged in, and we're both on varsity. I don't know how to log in though. I can't log in. Yeah. Okay.
All right.
Let's go.
Now, because when I converted this to exponential, I got 6 to the x equals 20, and I can't solve that, and my calculator doesn't help solve that at all. But what my calculator will do is tell me what that's equal to. Yeah. But you need the change of base formula because you have a TIN. Yeah. And you know what? Yeah. It doesn't matter whether you have an Inspire or a TI-84. You need to know the change of base formula. What's the change of base formula? What is it? In other words, you do not have a log base 6 on your calculator.
No, I don't.
You can't figure this out directly. But if you use the change of base formula, then you can.
I think you can. Like,
that's like right. I still want you to use the change of base. Okay.
Definitely, because I think he said that if you put it in a press to test mode, then you can do that.
Right. But then that means you don't learn the change of base formula, and you need to know the change of base formula.
Right.
It's easy, besides.
Mm-hmm.
What is it? What is it?
So would it be natural log of
You use any log you want. I can use common log or natural log, but it's the log of the upper number divided by the log of the lower number. And I don't mean bigger and smaller, I mean upper. 20 is higher up than 6.
Yeah.
So if this was 5, it would still be the log of 5 divided by the log of 6.
Okay, that makes sense.
And you can get that off of a calculator real easily. Just go ahead and put in log of 20, common log, and divide by the common log of 6. What do you get? Should get a number between 1 and 2.
Yeah, let me put that in. Oh, man. Oh, I'm sorry, Mr. Cow. I just, they looking at the teams.
Varsity roster.
I made varsity.
Hey, congratulations.
Oh, let's go. Yeah. Yeah.
Good deal.
Woo-hoo, yeah.
Good deal.
Oh, man.
Wow.
Man. Cool.
That's got to be exciting.
Oh, I'm so excited. Oh, my God.
Is that for the spring or the summer?
That's for the spring.
That's for the spring. So you made varsity at Chatfield.
Yeah. Oh, my gosh.
Fantastic.
Whew. That is cool.
Good for you, Dylan.
Wow, I'm happy.
Good for you. Wow. Yeah, I'll bet.
Yeah. Oh, man. I've been working, like, so hard. Like,
I know.
I've been doing everything in my... Yeah.
I'm sure you wanted it worse than anything. That's good.
Yeah.
It's always good to occasionally get what you want.
For sure. Just to say, like, you made varsity for a 5A
that's
school.
Huge.
Like,
that's huge.
Oh, that's cool. Oh, man.
That's very big.
Oh,
good for you.
Yeah. No.
Congratulations.
Oh, thank you. Thank you. Oh, man. That's awesome. Oh, man. Sorry. Okay, back to math.
Can you focus on math now that you know that?
I can. Oh, definitely.
Okay.
Oh, yeah.
So tell me what the log of 20 divided by the log of 6 is.
Okay. I got 0.523.
Nope.
No, is that not right?
Remember when we converted it to exponential, we got this?
Uh-huh.
Well, x has to be between 1 and 2.
Yeah.
6 to the 1 power is 1. 6 to the 2 power is 36.
Yeah.
So it's got to be some number between 1 and 2. So you're going to get it by, don't do the log of 20 divided by 6. Do the log of 20 divided by the log of 6.
Oh, I got you. Okay. And then you do divided by log of 6. 1.672.
That's it.
Cool.
It always helps to know a ballpark figure because that picks up your mistakes. In other words, that first answer you came up with couldn't be correct if I knew that.
Right.
All right. Let's look at 13.
Okay. Cool. Whew. I'm on that like buzz right now. You know, like when you get like super excited.
Oh yeah. Oh, I'm sure.
Man.
Oh
yeah.
Hopefully you can give 13 more minutes attention to math.
I think I can.
And then you can go celebrate.
For sure.
So how do I evaluate this?
All right, cool. So we would do, oh man, what did I just drop? So set it equal to x. So it would be 2 to the x is equal to 5.
Can I solve that? Is that
No.
No.
So you would have to do log.
Okay.
So
now what are we going to do? We're going to set it equal to what?
Log base 2 over log base 5?
No, the upper first, the upper on top, the lower on bottom.
Gotcha.
Matches exactly what you're looking at. The 5 is higher up than the 2. I don't mean bigger. It's just located higher up. Always make that your numerator. And you can actually use natural log, common log, log base 117 if you want. These ratios are always the same.
Okay.
Now, by looking at 2 to the x equals 5, I know that x has got to be greater than 2, but it's also got to be less than 3 because 2 squared is 4, 2 cubed is 8. So we're looking for a number between 2 and 3. What do you get when you do log 5 divided by log 2?
Okay, let's see. Whoops. Let me see here. 2.322.
Yeah, that makes sense.
That does make sense.
2.322. Okay. I don't know how many places he wants you to round it off to, but
yeah, it doesn't say on here, so yeah.
Condense.
Okay.
Now here you have to use those 3 log rules. And you usually want to go in reverse order.
Okay.
In other words, you know the 3 log rules I'm talking about?
I believe
log of a times b equals log of a plus log of b. That's rule number 1.
Okay.
Log of a divided by b equals log of a minus log of b. That's rule number 2.
Okay.
And maybe most important, log of a to the b power equals b times the log of a. That's number 3, and you almost need that all the time.
Okay.
So remember, we're going the other way here. So what we're looking at is this for each of these. So your very first step should be to take that leading coefficient, make it an exponent.
Okay.
So what's the next line?
So the next line would be, so would it be log s to the 10th?
The leading coefficient is the exponent.
So leading
not the base. Okay. You got the base right. It is base 10, but the leading coefficient is 4. So that's the same as that.
Yeah, right.
In other words, that third log rule allows you to take the exponent and put it in front. So 4 times the log of s is the same as the log of s to the 4th power.
Okay.
How about the second term? What's that?
I said log base y to the 3rd power.
Well, it's not base y. The log of y cubed.
Yeah.
Both of these are common logs. They're base 10.
Okay.
Now you want to use rule number 1 to put it into a common or a single log expression.
Okay.
What's the log or what's the argument?
So now we would do, let's see. How would it be?
Remember, multiplication becomes addition. Therefore, addition becomes multiplication if we're going the other way.
Okay.
So it's s to the 4th times y to the 3rd.
Gotcha. Okay.
Okay.
Cool.
And it's just as vital to be able to go both ways. So there's no preference for being able to separate. Being able to put it back together again is just as important.
Okay.
Okay? So first deal with the leading coefficient, always.
Yeah.
What's the next line?
So it would be leading coefficient. So would it, okay, I think -2 log 2 of 18.
Hold on. There is no leading coefficient on that first term. That does not have a leading coefficient.
Okay.
1, but, okay, the second term does, though. What do I do with that 1/2?
You'd square it, right?
No, you make it the exponent.
Make the exponent.
Rule 3, when you have something in a log expression, Rule 3 allows you to take the exponent and bring it down as a coefficient. So if I'm going the other way, I want to take the coefficient and make it the exponent.
Gotcha.
So what's the next thing I should write?
So minus log 2 to the 4 to the 2nd power. Oh.
Not the 2nd power, the 1/2 power.
Okay.
Now look hard at that. Make sure you understand what we did.
I think so. Is that okay?
All I did was move that coefficient to the exponent. That's all I did.
Gotcha.
Didn't do anything else. That's all I did.
Gotcha. Okay.
Whatever that coefficient is becomes the exponent.
Okay.
All right? Now, use the rules for subtracting 2 log functions to put this into a single log function.
Okay.
What has to go in the argument? Is it multiplication, division, subtraction, or addition?
Division.
Okay. What's being divided by what?
So within the parentheses, it would be, I remember this. So it would be log of 18 over 4 to the 1/2.
Yeah.
Okay.
Well, what's 4 to the 1/2? What's the square root of 4?
2.
So now we have the log of 18 divided by 2. Well, that's the same.
Log 2 of 9.
Log base 2 of 9.
Log base 2 of 9, yeah.
It scares me when you say log 2. In other words, you always want to put in that word base. You just do.
Okay.
Because there's so many numbers. You have a base, you have an argument, and then you have something that it's equal to. Okay? Well, now this is another one that if I were to try to evaluate that, I would have 2 to the x equals 9. That's not a number I know.
No.
So how do we evaluate log base 2 of 9 equals, use the change of base formula?
Yep, is equal to x.
No, that's using the other method.
Is that using the method?
I could do that, but then I get this. And that doesn't help. I cannot solve that. I don't know how to solve that.
No.
Nobody does.
No.
However, I don't have to solve this one that way. I got a calculator. Use the change of base formula. What's the log base 2 of 9 equal to using the change of base? You have to use the change of base formula because your calculator doesn't have a log base 2 key on it.
Okay.
So you got to turn it into either common log or natural log.
Okay, probably common log, right?
Doesn't matter. Either one.
It doesn't matter.
No.
Okay.
These ratios are the same.
Okay.
Tell me what the fraction is.
So it'd be log base.
Huh? Okay.
Just
log, common log.
Log of 2, or log of 9 over log of 2.
There you go. And that fraction is the same as natural log of 9 over natural log of 2. That's the same number as that.
Okay.
So that's why I say it doesn't matter what log you use. It's also the same number as log base 17 of 9 divided by log base 17 of 2. In other words, when you're looking at these ratios, they're all the same. So the base doesn't matter. It's the numerator and the denominator. The numerator is always the upper number. The denominator is always the base.
Cool.
All right.
Okay. Sweet.
That was 15.
Yeah.
Okay, now they're going to get, we've got time for maybe one more.
Yeah.
The log, and they're going to use variables this time.
Mm-hmm.
And they want you to expand this.
Mm-hmm.
So just to be helpful, I'm going to put that.
Okay.
Okay. Now, notice we've got exponentiation going on, we got multiplication going on, and we got division going on.
I think I know what to do for this one.
All three log rules.
Okay. So would it be log base b of 5 minus log base b of x squared minus log base b of z?
Is 5 multiplying or dividing the x squared?
Oh, it's multiplying. So add.
It's adding then.
Yeah.
So it's log base b of 5.
Uh-huh.
Plus what?
Plus log base b of x squared.
Okay, good.
Minus, or plus, yeah.
No. The z is a divider.
Gotcha. So
when you're doing division, it turns into subtraction.
Okay. Minus log base b of z to the third.
Okay. Now we haven't fully expanded it because we still have these exponents.
Okay.
So let's do what we can with those exponents. Nothing more to be done with that term, but what about this?
Let's see. We need to get rid of the square.
Exponent.
Exponent, right?
What can you do with the exponents on log functions?
Put a 1/2 in front of the log, right?
Not a 1/2. What is the exponent?
It's 2.
Okay, that's what you want to put in front. In other words, it's
plus
really
2
easy.
log.
It's not hard at all. Because all you do is you take that and you put it there.
Right.
So it's 2 log base b of x. Last one.
And then minus 3 log b of 2.
Right. Of z.
Cool.
Log base b of z.
Yeah.
Okay.
Sweet.
Dylan, I will let you go celebrate. Congratulations to you. I will have to come out and watch some of your ball games.
Thank you. Definitely. Our first game is Saturday at Chatfield. If you wanna, if you wanna come, but it's a scrimmage. It's not a Chatfield.
Now, you'll be on the varsity?
I take that back. Yeah. So I'm gonna be on varsity. It's actually in Parker, so I don't think that'd work out.
Okay.
But on Tuesday,
next time you have one at Chatfield, you let me know, and I may come over. If I don't have anything
definitely
going on, I'll come over and watch a little bit.
Sweet.
That
sounds good. Oh man, I'm excited.
I'm sure you are.
Yeah.
Yeah, I can't imagine anything that would excite one more than that. Other than getting on varsity and then winning the state championship or something.
Oh, that'd be cool.
Yeah.
I think part of the reason why I made varsity is because of, so we did Coach Johnson cares a lot about strength, and we did push-ups, pull-ups, and sit-ups.
Yeah.
Push-ups, and we had to do it all under 60 seconds. I did 68 push-ups, 59 sit-ups, and then 19 pull-ups. So
that's tremendous.
I mean, I've gotten so much stronger than. Yeah.
Great. Fantastic.
Yeah.
All right. I got to go because I got an 8:30.
Yeah, go ahead.
All right.
Awesome.
All right. Have a good night.
Thanks, Mr. Cowan.
Bye-bye.